Hi everyone, welcome to this Math 082 video. In my previous video on section 1.3, I defined slope and taught you how to identify the slope of a line looking at the graph. What I didn't do in the last video is talk about vertical and horizontal lines. So this video is exclusively devoted to teaching you how to understand vertical and horizontal lines. So I just wanted to mention before, we already talked about slope, and we told ourselves that slope tells us how steep or shallow a line is. Again, it also tells us whether the line is increasing or decreasing, in other words, whether it has a positive or negative slope. We also talked about the different ways to define slope, such as rise over run, or the change in y over the change in x. So let's get started. A vertical line will look like the following. It is straight up and down. So what is the slope of this line? So what I always tell my students when I teach this in face-to-face classes, I tell them to think about driving up this line. If this were a road, what would happen if you tried to drive up this line? Well, that's crazy, right? If this is the earth right here, and you're standing right here, you can't drive up this. That's not a road. That's like a cliff, okay? It is very steep. In fact, we sometimes will say that it's infinitely steep, okay? So our slope is undefined. So how can we really prove to ourselves that this is undefined? Let's think about taking a few points from this line and actually finding the slope of this line using the slope equation. So let's say I have the point 2, 0, and then I have the point 2, 2. So the slope equation tells me to do this. Oops, sorry, not x, y. y2 minus y1 over x2 minus x1. So we need to go through and label these. So it doesn't matter which one you call 1 or 2. So I'll just call the top point 1 and the second point 2. So that means I'm going to have 0 minus 2 divided by 2 minus 2. Well, that gives me negative 2 over 0. And mathematically, we cannot divide by 0. When we try to divide by 0, numbers go crazy. Depending on whether they're positive or negative, they either approach positive infinity or negative infinity. So we say that the slope is undefined. Let's think about the equation of a vertical line. So another way to think about this equation is to do what we just did before, which is to pick a bunch of points. So we already have the points 2, 2, and 2, 0. Let's look at this third point here, which looks like 2, negative 2. And just for fun, let's just throw in one more point here, 2, negative 4. So sometimes we'll try to put things in y equals mx plus b form, right? But the problem with this, of course, is that our slope is undefined. We don't have a numerical value for our slope, so we can't really write this piece. In fact, we can't have a y equals anything at all. So what do we see here? Well, if you look at this set of ordered pairs, do you notice that all of your x values are exactly the same? Right? So you can literally let our y value be anything, but x is always 2. So that's how we write the equation of vertical lines. We say x equals, and then wherever the x value lands, right, you can put a vertical line anywhere. So that's how we write vertical lines. So they have undefined slope, and the equation is x equals whatever, wherever it's crossing the x-axis. Okay? So now let's talk about horizontal lines. The way I encourage my students to think about this, again, is to think about driving. Okay? So if you have a tiny little car here, or maybe a big Mack truck, I don't know what you drive. Okay? If you're driving on this road, okay, are you driving uphill or downhill? Well, it's neither one. This is, I would describe it as a flat road. It's not sloped at all, so it has a slope of 0. Okay? So when we think about putting something in y equals mx plus b form, well, that's really easy because we can just put 0 here for our y. So we have y equals 0x plus b, which means that y is just equal to whatever our y-intercept is. Can you find the y-intercept on this graph? I found it right here. So this point is our y-intercept, okay? And it looks to me like this y-intercept here is 0, 2. So when we write the equation of horizontal lines, all we have is our y-intercept. Because, why? Because our slope is 0. So if it made you feel better, you could even write y equals 0x plus 2. Okay? We don't do that as math people because we know that 0 times anything is 0, and so we just leave it as y equals 2. Realize you can't do that over here with our vertical line because, again, we don't have a slope. Also, look, this is parallel to the y-axis, so not only is the slope undefined, but we also have the problem that since it's parallel to the y-axis, there is also no y-intercept. Okay? So because of those two facts, because of your slope being undefined and because it doesn't have a y-intercept, the equation of a vertical line is different and unique from a horizontal line or a line with a finite slope.